So we're back on this Colorado that I was just doing the video on the micron gauge, the video prior to this, and I decided to make this one of those vehicles that are different. Let's see, I have the RPMs hovering somewhere between 1500 and 2000 RPMs. I have a high side of 200 psi, low side of 31 psi. You can see our saturation temperatures. HVAC guys, don't pay attention to automotive, because this is a variable displacement compressor. And look at our wow, look at that superheat. Damn, isn't that high? And our subcooling. Now this is for talking to HVAC guys. And but look at our temperature out the dash. We got a 36 delta and we got 42 degrees out the dash. Our ambient temperature, let me get my hands out of the way, go back. We're only 65 degrees outside. Look at that, look at that. 65 degrees variable. Why is it so high? Well, this is normal on this vehicle because that's the way they have it programmed, when the way it goes. That's it. Haven't you seen, if you've watched many of my videos, and I talked about variable pressure and especially high efficiency condensers and everything like that, you may have noticed that at 65 degrees ambient temperature, often the high side pressure usually is barely over 100 psi. It's like 97 psi, 105 psi, maybe 120 psi. This one's 200. And you got this really high, look at our liquid line temperature there, but look at our superheat. Well, unlike the rest of the cars out on the market and HVAC guys who are just thinking regular residential split system, this has an internal heat exchanger where it's actually swapping a little bit of its cooling here. If you see this liquid line right here, you see this suction line right here, well actually as it goes in here, there's a tube that goes from here up and around, or actually it's over here on this one, it's here. It goes here, up and around, and you see how this line is bigger than this line? Within this fitting, the liquid is actually traveling around this cold suction line, and the heat is being removed from the liquid. High pressure liquid refrigerant is being removed through this internal heat exchanger right here. And our high side gauge in this line is actually not connected to the system other than reading pressure from that point to here. This has nothing to do with the flow of refrigerant. All it is a port to draw vacuum and read pressure. That is all. It has nothing to do with flow. The flow is actually going from here, going inside this fitting. This valve is drilled out and ported. It's going around a bunch of little tubes. And if you actually look really, really carefully at this tube, you can actually see little squared off sections. Those are like little ports that the liquid is traveling. The liquid is traveling inside. And let's see if we could see it on the other side. And we cannot see where the liquid line exits and goes into the expansion valve. So this is one of those ones where your engine RPM, right now it's idling, your engine RPM makes no difference. It doesn't change the high side, it doesn't change the low side. Your ambient, it seems like it makes absolutely retarded difference compared to other cars. When you see me do maybe 100 other cars that aren't specifically this one, at a low ambient like this, you usually see this barely over 100. But yet this has just been charged back to factory specification. It's full, it's running, it's operating. And that's why I say do not pay attention to pressures. Pressures don't mean anything on automotive anymore with the ones with the variable displacement compressors. On top of this, you have the internal heat exchange tube right here that really throws off your numbers. So if you're used to regular split system, your old Goodman straight at 4-ton unit or something like that, what you're seeing here I know it's not a 42 subcool. That's a false reading. But that's because we have an internal heat exchanger, and this is how this system was designed to operate. And the displacement of the compressor is actually forcing the pressures to be what they are, whether I have high RPMs or low RPMs. It won't make a difference, but yet it'll always come out the same out the dash, temperature wise. Not the greatest explanation, but this is one of those oddball vehicles that sticks up there in the higher pressure because it has a variable fan on it, and the HVAC module is telling the fan at what RPM to spin to flow a certain amount of airflow over the condenser to keep its head pressure where it wants to see it. Not where I want to see it if I had a little can and I was shaking it, trying to squirt in, trying to go beer. If I tried to go beer can cold, I'd be squirting all day long, because this is never going to get beer can cold and sweat because of that internal heat exchanger exchanging some of the heat energy out of the liquid refrigerant coming out of the bottom of the condenser right here, out of this tube, and exchanging it so the temperature of the refrigerant coming down the suction side is a higher temperature. So if you were trying to read, where's my gauge? Way down there on the suction line, you get this half-assed, oh, where the hell did it go? Ah, lost connected. Oh, it shut off. Timed out. I've been on so long. But you see why it's almost 60 superheat, because of that internal heat exchanger. Oh, now we're 97 superheat. Oh my God. And this is what the factory dealt for it to be. It operates like this. It's the way it's manufactured. This is why stop trying to use the old school methods. Don't try to use the PT chart. Doesn't mean anything on these vehicles. If you're old school and you've been in the trade for 20 or 30 years, whether you're a refrigeration guy, whether you're an HVAC guy or an automotive guy, stop trying to use pressures and temperatures when it comes to these units with the variable displacement fans, variable displacement fan, internal heat exchangers. Everything you read in books, throw it out the window. All right, I'll see you guys.